discussions. For our closing remarks, I would like to introduce Matt Schumpert, the Director of Product Management for Datameer. Matt has been working in enterprise software for over 10 years in various capacities, including sales engineering, strategic alliance, and consulting. He also holds a Bachelor's of Science in Computer Science from the University of Virginia. The Escape Big Data Analytics Conference is proud to present Matt Schumpert.
All right, I'll be low. Thank you, everybody. Thanks to Faisal and everyone for inviting us back again. If you were here last year, our founder and CEO, Stefan Worship, delivered the keynote. We're also good friends with Dr. Phil Shelley from this morning. A little louder?
Yeah.
All right. So fair to say we're friends of the Escape. So thanks a lot for the time today. I think a lot of the sessions, as I walk through the halls, were very hands-on, very down the weeds, bits and bytes. As a lot of you are pursuing a career in data science or shifting careers into data science, or already maybe IT practitioners doing data science work or big data analytics work. I'm going to bring it up a level for the closing remarks, talk about industry level and sort of technology stack level trends and dynamics that I think might be interesting for folks who are getting deeper into the field, if you will. So as soon as I turn my clicker on, the title of the talk will be called Haas, Badas, or you can pronounce it any way you want, and other observations and predictions about the future. Anyone heard the term Haas before? Yeah? What, last year? Not UC Berkeley Haas, by the way, that other school. I got Northwestern alumni in the family, so home turf. Okay, so the agenda is, first of all, talk about these macro trends, and you say macro, grain of salt, because big data is still minuscule when it comes to overall IT or even just database industry by way of comparison. So what's happening in the market overall, what's happening with the practice of big data analytics, and I think of data science as kind of a subset of big data analytics. We sort of tend in Datameer towards the simpler kind of data queries, data processing, data questions, if you will, more akin to the traditional business intelligence market. But I'll focus a bit on the data science piece or the advanced analytics piece of big data analytics. And then given that state of affairs, what can we do to unlock more value for ourselves and for the consumers of our work product as data analysts and data scientists? I was previously a computer scientist and was mentioned helped customers in the field. Now I'm on the product side of the house, building the product, fixing all the things that I thought were broken when I was on the other side of the fence. So I know a lot about sort of the competitive landscape of tools, but also methods, architecture, why architecture matters, and why a better architecture can lead to better results. And then we'll talk about our favorite terms, Haas, and still figuring out how to pronounce it. The very latest layer in the technology stack, if you will. Okay, so macro trends in big data. If you guys are following this stuff, Wikibon does a pretty good survey of the vendors and their revenues and investments as well. So here's where we are in the 20 to 30 billions of revenue. This number is a little bit fuzzy because what is a big data product? What is a big data sale? If I sold 10 terabytes worth of a data warehouse, does that constitute big data? If it was only structured data, does that constitute big data? What's not fuzzy is that there's a lot of venture capital being poured into new companies producing new software services infrastructure. So in 2013, there was $3.6 billion of venture capital just into, let's say, big data-centric investment plays for venture capital. So new companies or new products that are squarely in the big data space. Where's that money going? If you break it down, there's the infrastructure providers. Hadoop is kind of leading the charge. When I started at Datameer 5 years ago, it wasn't quite clear whether the Cassandras of the world, the NoSQL databases of the world, were going to become a bigger portion of the market share. It seems right now that Hadoop is kind of leading, but there's lots of other technologies loosely related to Hadoop, things like Spark that have gained a lot of momentum recently, and there's companies like curating the infrastructure, right? So cleaning it up, packaging it, making it available for sort of industrial grade usage and consumption by large enterprises. And those are some of the logos that you see here on the slide. So there's kind of the wrapping the technology itself and industrializing it or commercializing it. And then there's obviously the massive growth in infrastructure as a service, which is these cloud platforms like Amazon, Microsoft Azure, really come into its own lately to solidify itself as kind of a #2 cloud platform. I think they were here today. And then Google Cloud Platform as well with some great technology. So this is generic cloud infrastructure, but as some analysts have said recently, big data is kind of the killer app for the cloud because more and more of the data that people want to analyze that's very large, which means it's hard to move to the ground or to the cloud, is being generated in the cloud. And so you're going to get the best savings and the best sort of cost profile for your deployment if you do that deployment close to where the data is. And if the data is in the cloud, then and these are big deployments of large systems with lots of money being spent, that's a great use case for public cloud infrastructure. And then there's Hadoop as a service, which we'll talk about later on in the talk. Just as a teaser, some logos, you may have worked with some of these technologies. This is actually the dinosaur in the space of Hadoop as a service. It's been around since 2009, but now Microsoft and a couple of their pure play vendors producing just specifically products that are Hadoop as a service. What does that mean? It means you really don't have to know anything other than how to use it. So you don't have to administer, install, service that environment, monitor that environment as you would on-premise infrastructure. And then, of course, there's analytics tools and platforms out there. I work for Datameer, but there's lots of others in the data science field. Again, these are relatively new companies, been funded in the last few years, producing tools to get you more leverage, get you more productivity. And then the big companies are also touting how much they're contributing to the technology directly. So Microsoft, for example, is talking about all the contributions. There's a little bit of a holy war going on in Hadoop, and there has been for a while around who contributed the most. Like I contributed 10 million lines of code, you contributed 12 million lines of code. At the end of the day, what does it really matter? But a little bit of, as our CEO says, my Hadoop is bigger than yours. And this is kind of the Microsoft instance of that. Scanning the source code and seeing how many contributions were made. And the idea is that, well, if we contributed the most, we know the technology the best. And if the base technology is available from all vendors, then you want the expertise that comes with having built it. So in other words, the people who contributed the most, even though it's a similar product, will help you the most when there's a problem, right? So there's a reason behind that. Okay, so we've been pouring and pouring all this money into big data. Maybe it's a bubble, maybe it's not. What's coming back? The total market, the total revenue being generated in 2014 is estimated $27 billion. Software services infrastructure, 10 billion of that is actually services. The cloud piece of that, which we'll get to later, is small, relatively speaking, but estimated to grow extremely, extremely quickly, which leads us to those layers we're going to talk about at the end. That's a pretty impressive growth rate for an area of this technology stack. So those would be the Hadoop as a service and the infrastructure as a service to support Hadoop specifically. That's where those figures come from. Where is the money not going? Anybody have a guess?
The trash?
That's debatable, actually. That's definitely debatable. The money is not going into traditional data warehousing. So here's a company, his name I probably shouldn't mention, but they're a big behemoth in the data warehouse industry, probably the biggest company in the data warehouse industry. You can easily figure out who they are. But you'll notice that their stock chart over the last 5 years followed the macroeconomic trends quite nicely until this point, at which point it quickly stopped following the macroeconomic trend and began declining rapidly, and now looks much more like a value stock than a growth stock. This company sells data warehouses, and so what was this? This was the year when Hadoop really took off, right? And so basically all of their growth is being siphoned off, is being stolen. People are still maintaining the technology and buying some new instances of it, new licenses, but not nearly enough. And so you don't see this with the Hadoop technologies, but it's pretty dramatic. Again, especially given the macroeconomic situation of the last few years, which has been quite positive, right? So the other thing that's happening broadly is it's a very noisy market. So this is something an analyst did to survey the big data analytics space. This doesn't seem very useful to me. This is everyone basically who decided to put a Hadoop sticker on their product. Be wary of them because they're really attaching themselves to the keywords in Google usually, or really just trying to look more relevant by putting out a press release and saying that they have a product. But a lot of them do have a product, so how do you sort of sift through all that? That's definitely painful. So that's a pain point that consumers of the technology have right now, is that every of the existing vendors that they had called them up, and all the new vendors are bombarding them and telling them they're going to do big data analytics, and it's going to get the newspaper for them and make their coffee, and they have to separate the wheat from the chaff. But even so, everyone's saying they're doing it. You know, a little bit like teenage sex, right? Why isn't everybody doing it? Everyone's talking about it. No one's actually doing it. More people are doing it than that, but still, some people aren't doing it. And why is that? Is that the barrier to entry is still high. To set up a 50 terabytes, so you have 50 terabytes of data, you want it stored, you want to analyze it, costs about $200K still today in overall total cost of ownership. So hardware, a little bit of software, and a lot of human capital. That's why everybody's doing data scientists, right? But it's not just data scientists; it's really the system administrators that represent that. So the barrier to entry is still high. And there's also still a huge skills gap, which is great for everybody in this room, obviously. There's a lot of unfilled jobs. I heard from the CTO of the U.S. government last night, 5 million unfilled IT jobs, and we'll talk about data science. So that's the market. Now the practice of data science, the practice of big data analytics, digging into that a little bit more, to the point I was just making 190,000 unfilled data scientist jobs according to a McKinsey survey. So that's great news. There's opportunity there. The salaries are high. There's issues, unfortunately, with data science. Even today, the traditional, and they very much mirror, in a lot of ways, the traditional predictive analytics pain points, and we'll talk about the life cycle of doing predictive analytics as well. But it involves a lot of esoteric skills. Again, why a lot of people are in this room. Get paid good money. Not a lot of people know how to use those things. They don't know what a random forest is. I don't either. Long cycle times to deploy something new. So you can't recycle or push your model into production daily or hourly or every time fresh data comes in the way you'd like to. It could be a quarterly or even yearly deployment cycle in some of these companies. Low transparency, so like what actually happened, and we'll talk about why. Sometimes the guy deploying the model or coding the final version of it didn't actually conceive the model in the first place. So the mathematician built something, and then somebody else had to recode it, didn't know what happened when their code had a problem. And then you have data and applications in different silos, right? So not all the data that you need in order to come up with the best model and apply your algorithms to it is in the same place. It's hard getting that data together. Once it's together, it's not your father's data set, right? You're not your mother's data set. It's not just transactions, right? It's not just the customer profile. It's it's tweets, it's email, it's all kinds of machine logs that are very raw, right? It's encoded. There's all kinds of public data out there, and this makes the data preparation task much more arduous for data scientists who really weren't trained in data prep. They were more trained in algorithms, statistics, and machine learning, right? It involves sampling, so basically you're guessing, you're hoping that your model, when you downsample to 1%, it's going to scale up to the full population and be accurate. It's not overfit or what have you. And these tools and these systems were very, very expensive. But before you get depressed, the work product was extremely, extremely valuable. So what you built was could actually make a huge difference in the top line or the bottom line of the company, and be actually really transformational, and stop fraud and things like that are useful to us. Another issue is that the signal-to-noise ratio is dropping. So there's more irrelevant data that's really needs to be filtered and weeded out. It may be dirty, it may throw off our calculations, but mostly it's irrelevant and needs to be filtered out. And how do we do that? We need tools to be able to do that. So that makes it harder as well. We can't presume clean data the way we could before. So we work with folks like Bank of America. They have a group specifically who are the certifiers of clean data, right? So the data comes through the data stewards group, and before it goes into credit risk groups, for example, or fraud groups within the bank, there's this stewardship process by which they check off, the data cleanliness across 100 checks and say, yep, it passed 100 of these checks, that's clean data. Now you can actually estimate the risk, because the FICO score wasn't negative 5,000. Oops, we made a mistake, right? And there's one more problem as well, right? So there's other problems. So the workflow has always been painful with predictive analytics, and still, even in the big data sphere, sometimes even worse. And I touched on this before, but the recipe is you pull some historical data, you downsample that because you only get one machine in the non-big data world to do your model development or your model training and validation. You cleanse and pre-process the data to that point we just made. Then you choose the right algorithm, and you test about a bunch of different algorithms. Then you tune them, implement them in a model development environment, SAS, SPSS, whatever, wonderful Chicago company here. And then you have a training set, so you got to get that training data. Maybe you want to validate now. If you want to validate on a larger data set, you might have to do that in a different environment. Like you want to do your validation on Hadoop. We have a way that you can validate across your entire data set, really, using the power of scalability of a platform like Hadoop. But sometimes you might need to move the model around. And then, as was mentioned earlier, a lot of times you can't execute that model and put it into a production transaction processing system that's going to actually give you the correct interest rate or block the fraud or whatever that might be, and give you the right content or the right marketing. You have to code that again in a separate programming language. So it's a programmer trying to understand what a data scientist did, replicate that, and then go through their software development lifecycle around that and push it out into production, right? And then, oops, overfit, or something's wrong with my model, I need to tune it, something changed. The market is drastically different today than it was yesterday. Like CME, for example, they use our product, and one of the things they do is they tune the predictive models that actually make algorithmic trading decisions. We don't execute the models, but we get market data in every few hours and actually help them to update the coefficients of those models, on an intraday basis. So a lot of fine tuning involved, and you want to have the most agile or lean process around that as possible. So rather than a couple software development life cycles, you'd like to have something that's really agile, that you can operationalize and update your model quickly. And in order to do that, the best thing is to have actually one environment, end to end. That's not always possible because we're talking about a lot of different disciplines here. Of, can I talk to a mainframe? Can I apply that matching algorithm or that cleansing logic or that join and union? Can I actually define those algorithms or all those algorithms that I want supported, or do I need to custom craft my own with my own logistical regression with R? And then how do I test it quickly? How do I quickly ascertain if it's properly trained or not, or validated, and then pushing it into production as mentioned? So try to move towards a lean process by putting as many of these tools under one roof as possible. And then when you try to apply that same life cycle around predictive analytics to big data, you can run into other problems, in that these tools often aren't, at least the legacy platforms, aren't natively designed to work at the scale of big data. So they're not necessarily designed to work directly on hundreds of terabytes of data efficiently. They're all kind of in their own little world. And then there's programmatic approaches. There's R, which is not truly native to Hadoop. So it's a little bit clunky when you try to make it work seamlessly with Hadoop. It's also a programming exercise, right? It's not a tool. And a lot of people know SAS and know these other tools, but they don't know ours to learn a new language. And then there's frameworks that sit on top of true big data environments. So Mahout runs on MapReduce, and then you've got Spark, which can also run on Hadoop and has some machine learning algorithms within it. A library. This tool, some of them are still immature. Again, you still have to write code, and there's less support out there for you from various vendors and consultancies if you need help to implement those things, right? So that's very, very depressing in some ways. There must be a better way. There is a lot of things that we can do to mitigate some of these issues. And in general, I think some of the principles for unlocking more value and getting to sort of big data nirvana quicker will be kind of the second half of the talk here. The first thing is what actually will give you leverage over that previous state of affairs that we just talked about, right? That previous life cycle, those previous pain points. One is speak the language of the business. Go into that. Generate, don't write code if you can. Simplify data integration and preparation. 80% of a lot of data scientists' time is wasted in pulling data and cleaning it and preparing it for analysis. And you have this small sliver that they actually get to do the fun stuff to really solve the problem and build the algorithm. And then from an architecture perspective, of course, don't try to funnel all your data through a small pipe or not a very powerful system to crunch the analysis. Move the computation to where the data sits. Leave the data in place, leave the data where it is. So when we don't speak the language of the business, we talk about things like CART, k-means, matrix factorization. A lot of you guys probably know this stuff. Statistical regression, random forest. It's really worked well in a business school presentation. They were like, what? Support vector machine. Support what? But really, it's not that complicated, some of these things, right? What is clustering? It finds patterns to group data, right? Did we really have to talk about k-means and centroids? Really? Right? Decision tree. Automatically identifies the attributes and likelihood that lead to a result. Do we really have to talk about CART? No, not necessarily. Column dependencies, or column analysis, automatically quantifies how much an attribute influences another attribute. What influences what, right? Do we have to talk about Pearson's correlation of mutual information? No, not really, right? Recommendations, right? Automatically predict interests of a person based on historical observations from many people, right? Anyone who uses Netflix can understand this, right? Do we have to talk about matrix factorization? No. It can be really simple, right? Generate, don't write code. Speak the language of the business. I wish we hadn't put, I think we changed that. It doesn't say k-means anymore, it says clustering, right? Keep a lot of the esoteric jargon out of the tools if possible. What do? You lower the barrier to entry, you broaden the base of users, more analytics work can get done with people who are closer to the business, right? No offense to people who like to code. Same thing with all these other algorithms, right? It can be really easy. It can be point and click, why not? Microsoft did that with Visual Basic, we all do it. Word processing and spreadsheets, why can't we do it for especially the more well understood algorithms with less configuration required, right? So that's one thing you can do. And there's other products out there, not just to talk Datameer all the time, that are designed for data scientists to give them a workbench that gives them leverage over sitting at the command line in the way that Word gives you leverage over text editor, right? Again, no offense to people who like text editors, but okay. So there are a bunch of other tools out there that you can check out that will help you to generate code faster, that will speak in higher level abstractions, and that will have a bunch of point-and-click tools built in to give you more productivity. The next thing is a unified architecture, and this is a really big problem. Going back to that survey of the market of all those companies on that massive smattering of logos at the beginning. The problem is that those logos don't really tell you about the architecture. They tell you what space that the company is messaging in. But what does that actually mean? Like, where does your data sit? How does it move? How scalable is the platform? How are all the components interconnected, and so forth? And so Hadoop has been well on its way to delivering a unifying architecture for big data analytics, which is actually a really great thing. It's kind of about time. Hadoop's been around actually since the core technology's been around since 2003. Google invented it. It's really been almost 10 years now that we've had Hadoop proper. And so over time, we've been building this unified technology stack at the system level or the hardware level, as most Hadoop technology is actually deployed on premises today. It's not surprising, but it's not deployed in the cloud. And what it means is the existing hardware vendors, one said, yep, I got a Hadoop product, and so they'll build hardware that's tuned specifically for Hadoop deployments, right? So the specifications of the hardware are specifically there for Hadoop. I think IBM was here today, and you've got other vendors working on what we call the data platform layer, right? Specifically designed to work with that specialized hardware, right? Intel also invested almost $1 billion in Cloudera, right? So they're working very closely to marry these two on encryption and other things. And then analytics platform, of course, I'm going to put Datameer here, that is designed, again, natively to work on top of that data platform, right? So it's not like we're over here in our database world, relational database world, data modeling, SQL. We're just tapping into Hadoop over here and trying to pull out the data and then do something over here in our little world. No, it's actually sitting squarely, directly on top like a layer cake. So the more of this you got, the more of this you can do. And then you can build solutions on top of that. And what do we see, of course? Customer analytics, we call that. So customer journey, plotting that customer's interactions with you through all these touch points and how they convert and upsell and churn, or fraud. There's Internet of Things applications. So we got a customer who's doing home automation, such as tracking you as you move throughout your house and predicting when you might want to turn on the thermostat. You open the window. Oh, good idea, right? Or a door opened and then a window opened coming home on a hot day, right? A window opened and then a door opened. That's a burglar, right? Let's look for all those patterns. Things like that. And then if you drill into kind of that second layer of the technology stack, as many of you know, there's a zoo of tools within that second layer, which have all kinds of crazy names. Pig and a zookeeper and a scoom and a fluke and an Uzi, and a storm and a spark to burn down the barn, I guess. And then you have all those different types of applications then that will be enabled by what we see now as kind of more of an operating system. So previously, generation 1 of Hadoop, it was basically an operating system that could run one application, which was MapReduce. Or an application server, you think about it in terms of middleware, they could run only one application, run an e-commerce application, for example. What if you want to run all these other applications? So now you can run all these other applications that have different requirements around responsiveness, around scalability, around resiliency, around security, around handling partial failures and all kinds of things that happen in the real world. And then you have other ways to express those applications from a programmer's perspective or from the data analyst's perspective, from someone who uses a spreadsheet. But the really interesting thing here is that this sort of operating system gives you this sort of multi-mode platform to build many different types of applications, and it provides really the frameworks for a new ecosystem of companies to go out and build apps like hundreds of companies and tens of billions or hundred billions of market value created on the relational database that can now be created on top of this big data infrastructure because you have a lot of the pieces already building blocks done for you, and you have APIs that hopefully will remain stable so they can run on different types of platforms. It's like running on different versions of Unix, right? You can run on different versions of Hadoop. And now companies can go and build vertical applications for Internet of Things, for telco, for financial services, whatever. And this is a great thing for, I think, a lot of you guys to think about as we go forward. The next layer of the cake is really going to be these vertical applications. So you've got a company that has a vertical idea that can really differentiate itself because of the technology, right? So a company like O-Power, if you go to your power company, PG&E in California or Southern California Edison or a couple other power companies, and you look at your electricity usage, it's actually coming from a company called O-Power. And one of the things they do is they gamify the whole thing. So they look at you, and then they look at your neighbors on the block, and then they compare you. And the most motivating thing for a consumer is not to be the slowest guy. Not to be the slowest guy, sorry, I'm looking at the clock. Not to be the most energy-consuming guy on the block, right? Not to be the guy whose energy efficiency is the worst. And so if you're in the bottom, quartile or quintile, you're very motivated to decrease your energy consumption. So what they do is they collect all the smart meter data, right, from all the consumers, and then they do analytics across that, and they sell that as an application to power companies. They don't want to build it themselves, right? And the scale at which that data they're capturing a measurement every second, every smart meter in the country every second. So think about the volume of data, the number of rows there. It would only be possible for them to be a profitable company with that scale of data using technology like Hadoop, because otherwise it would be too expensive. So it enables new industries, really, and new applications, and this is, I think, kind of one of the next frontiers. The other reason the unifying architecture is important is because in the data analytics process, you have these different stages at which previously specific technologies would be better or worse at different stages in the process. So what do you do, not just data science, but any kind of analytical process, even if it's a simple group by how distinct, you have to go through some of these or all of these stages, and this ends up being numerous steps, especially when you have many data sources. You don't even know what's in there. You have to assess it. And when you use these iterative algorithms, right? When we do clustering, we run over the data 10 times and try to get just the right buckets. So you multiply that all out, there's a lot of different passes and crunching over your data. You need something that's going to be efficient all the way down the scale from large data to what you finally look at on your dashboard. It's not going to be terabytes of data. It's going to be some number or 10 buckets on a chart or a graph. Previously, different types of approaches in memory, as well as the big freight train of all data processing engines MapReduce would be applied at different scales. The high end of the scale, you got this. The low end of the scale, you got this. They both have their drawbacks. Most importantly, it's not a unified architecture, right? You end up with kind of a split brain scenario. I got my big data over here. When it becomes small, it gets cast over here on this side of the wall, and it's like, oh, it's going to be big again because I have to ask the next question. So again, this doesn't follow this fourth tenet here, which is move the computation or the analytics to the data, right? So when you don't do that, what you get is a non-unified architecture, or maybe you're using Hadoop to bring in all these data sources that you have, semi-structured, structured. You're using the open source zoo of tools to pair that data and make it available for analysis. And then, because you need to then make that data available to somebody else who doesn't understand Scoop, Flume, Pig, Hive, and whatnot, you have to copy it over into another system. So you have to create a cube or aggregate this data and stick it into this other system that works well with the kind of interface that they want, which is I click something, I immediately see a response, instantaneous. I'm a business person, I'm lazy, or I'm impatient, I don't want to wait, and so therefore I have to use this technology, which gives me the instant gratification, as opposed to these smart people here who want to plan and wait and build their analysis, and that's often in memory or a relational system. But then what happens, right? So, oh, this isn't exactly what I wanted. Can you get me that data, please? Oh no, we have to write another pig job. Oh, can you guys develop that? Oh, okay. No, we actually have a full queue, or the next 7 sprints are full, sorry. It's going to take, 8 months. Oh, okay, so disappointment, and rinse and repeat, right? That's not a unified architecture. So what you really need is something that can operate and satisfy these people and satisfy these people as well throughout kind of the entire data pipeline, right? With the really raw big data, and you're extracting and preparing that data, and you're aggregating it and summarizing it down to go slicing and dicing and doing a quick and dirty visualization of that. You need a system that can handle all of that. So kind of like a hybrid car that works really well when you hit the gas from the stop, and it uses the gasoline engine, realizes once you're up to speed, it's actually more efficient and more pleasant to use the electric motor to keep us going, whether that be across a number of machines or actually on a single machine, because big data is great, but once you have small data, it's actually much faster to run stuff on your laptop than it is on a big Hadoop cluster. So something that can switch gears, if you will, automatically is kind of a good way to accomplish the unifying architecture for the entire data pipeline. Okay, great. So we have a unified architecture. We have good tools. We're still dealing with our on-premise Hadoop situation, right, by and large. That's what people are doing. So again, remember, $200,000, one Hadoop administrator, you can't make that decision lightly. You can't dip your toe in the water with Hadoop, right? You got to really dive in to a cold pool and see what happens, for the idea that you might learn something in the process of exploring your data, right? That doesn't always go over so well when you pitch that kind of a project to a CIO, right? We have this data discovery we're going to do. What are you going to find? I don't know. How much money are you going to save us? I don't know. Going to make us money? I don't know, right? Probably. All these other people are doing it. Facebook's doing it, right? Sounds cool. Sometimes the CIO will go to a conference, and he'll talk to a bunch of other CIOs, and they'll all be doing it, and they'll say, yeah, we have to do it. We definitely have to do it, right? Because he doesn't want to be the only guy at the summit who doesn't have a big data initiative. But in terms of the merits, it's hard to justify, just dive right in with $200,000. Enter Haas, right? Haas means Hadoop as a service, right? Hadoop as a service is actually an instance of something else. Anyone know what it is? Let's say this jargon. Somebody say it. Everyone heard of PaaS? Platform as a service. I first heard that, I'm like, this is a BS word. Now I use all these words. Hadoop as a service. Okay, Hadoop as a service is a platform as a service. What does that mean? Well, we're building a technology stack again. We're building a layer cake. This time, the layer cake is now in the cloud, right? That thing that Larry Ellison once said didn't exist, right? And I was selling a lot of it. Our previous stack was on-premise. What do we have now for infrastructure? We don't have Dell and NetApp and HP machines. We have Amazon, Microsoft Azure, and Google Cloud Platform machines rented by the hour. Infrastructure as a service, right? On top of that, we have platforms as a service. And one of those platforms is Hadoop. So what does that mean? Well, here, I don't have to buy and own, install, provision these things. Guess what? The same thing here. I can rent this software. I don't have to install it. I don't have to monitor it. I don't have to provision it myself, right? I don't have to have an administrator on staff and spend the human capital to keep that administrator around for that software. The software is fully rented, but it's not. We're not going to use the term SaaS because SaaS has kind of been co-opted by shrink-wrapped applications like Salesforce, where you can just log in and start using it instantly. It's not quite there. It's kind of a pizza crust, right? You need to take the pizza crust and do something with it, but it's a lot easier than starting with flour. So why would you do this? Again, we explained 200K in 3 months. It's not just a 200K, it's the time as well, right? If you're a line of business and you need to go attack some problem quickly to respond to some competitive threat, or you need to set up something for the Christmas season, right? Black Friday, you're a medium-sized retailer. You can't wait 3 months. You don't want to procure hardware. You need to get going as fast as possible. And so with these Hadoop as a service companies, this is one of them as an example, it's called Altascale. Again, venture-funded, founded company purely to provide Hadoop as a service, right? That means not just the software, but the operations team that maintains it, so you don't have to. You can call them at night, or they'll notice something, they'll wake up at night and they'll fix it for you. The other thing is, it provides a lot of the capabilities that the public cloud stuff does, but a lot of the advantages of the more high-end, more tailored service that a lot of hosting companies would provide. So you might have a hosted application where it's really built to your specifications, but not in your data center. There's companies that do that. The companies that do the sort of more do-it-yourself infrastructure like Amazon, you have this elasticity. So you only pay for what you use. You pay by the drink. You pay as you go. We call utility pricing. But you also have this elasticity so it can scale up and scale down automatically based on the demand, right? What's the workload? How many people are running queries, right? But it's closely connected to the data, right? Is the infrastructure really customized for Hadoop? Maybe not, right? Here, yes, that's true, but you don't have the elasticity of the cloud. You don't have the pay-as-you-go model, right? So people consider this not a capital expense, but an operating expense. And you don't have the fact that Hadoop is operating for you, which is the biggest barrier, is like going out and hiring that Cloudera certified administrator to be your system administrator, right? Or you just take your DBA and send them to the Cloudera school. But still, it's an expensive proposition to have that person, right, on staff. No offense to anybody who's doing that, of course. But that's why this sort of category of software has been created last year. So other companies like Qubole, and I mentioned a couple ones before, really this has been around. This was really, really early entered into the market in a way. But you have a service on the Microsoft Cloud, HD Insight, and you have these pure plays, and there will be probably more as we roll forward. Shrink wrap to do, and then what's left, right? Big data analytics as a service. Like, it's great if you don't have to buy all this and operate and monitor all this and even this kind of stuff. And now you're just basically at the level of writing my pig script, using Hive, writing my Spark job, writing my MapReduce job. But what if it were just a spreadsheet, right? And you could just say what you wanted to do in the language of the business, right? And you could say, okay, this is the decision tree I want to build, and it happens to run on 100 billion rows. And now I have a solution. And that's badass. Thank you, guys. I didn't just say that.
Yeah, I said
Badass.
badass.
Questions?
So the BDAS.
Big data analytics as a service. I think someone else has used that term, but we actually launched that in February.
So it's, you're using all the application layer protocols, right?
So we're using the Hadoop as a service, services, product services, whatever you want to call them, from companies like Altscale, Qubel, Elastic MapReduce or Microsoft as the backend to our product, as the platform. So instead, like for example, if you have a business objects or Cognos or Hyperion or MicroStrategy, these tools you just sit on top of your Oracle or your SQL Server or your DB2 kind of warehouse, right, in big companies. So it's really the same concept, right? The data platform is this, and we're the business intelligence or analytics platform that sits on top of them. And we use their APIs and we use their services, right? We interface with them, but the user doesn't have to know that. The user really is just driving spreadsheets. Other questions? Questions, comments?
Okay, so since no question, say for example, a data scientist from a company, they have data scientists, and the data scientists are good in R program and Python program, and they want to run some machine learning algorithm.
Yep.
What is your scope in that case?
So we have a couple. So primary, it's not our primary target. Okay. Our primary target would be, hey, great, have them go and use the tools, the development tools from these platforms to go and deploy their R code, right? It's great that you can still use the cloud and get up and running quickly and have the Hadoop platform already installed and ready for you. But at the application layer, you would use their tools, their development tools, instead of ours. That said, going back to the previous slides, we had the clustering and the decision trees and the recommendation. So we have some simple data mining tools that don't require writing code that an analyst can use. We also have a relationship with a company called Zementis, and they offer a predictive analytics execution engine, so like a scoring engine that actually runs inside of your applications, in production applications. But you can also use it for back testing and validation on large volumes on a distributed platform. So you would, in this case, build your model in SAS or SPSS, right? Say export to what we call PMML, the predictive modeling standard, right? And then Zementis would basically get injected into Datameer, and it would push down your model and would run your model on one of these clusters for you. So you point and click and say, take my neural network, upload it to Datameer, and now run it through the spreadsheet, right? And that would give me the scores, right, on the whole population of data, a huge amount of data in my Hadoop cluster, right? And then I can say, okay, now I'm really confident I've done a larger validation. Or I just have a batch process I want to schedule, I'll just leave it running in Datameer every day or every week, right? But the model development exercise would be another tool. So the model development exercise would be your, Weka or Alpine Data Labs, RapidMiner, some of the other ones I just talked about earlier. Other questions? Yeah, just to clarify that, like we're really the data science for dummies tool. Like we're really at the kind of the lower end of sophistication when it comes to the algorithms and the math, right? But a lot of sophistication when it comes to figuring out how to make simple computations run fast, efficiently across enormous amounts of data on Hadoop and make the user experience very simple so people can just filter, sort, group by, point and click their formulas together like they would in Excel. So really we're closer to the Excel user community and the SQL a little bit user community than we are to the R SAS user community. But at the end of the day, there's lots of business people who have simple questions they'd like to ask through a spreadsheet.
Well, thank you very much on behalf of all of us. Thank you. So on behalf of all the people that it took to put this together for you here today, we'd like to thank you so much for coming, and would love if you would join us downstairs on the first floor for our reception and networking event. So we hope you enjoyed, and thank you all very much.